Hey guys, Mr. Backerberg here. In this video, we're going to look at derivatives of higher order. Now, implicit differentiation can also be used to find higher order derivatives as well. So in here, we're trying to find the second derivative of y if we know that we've got the implicit function 2x cubed minus 3y squared equals 8. So the first thing we're going to do is just take the first derivative of everything in here. So if we differentiate this first piece, 2x cubed, we drop the 3 down as a multiplier, so that becomes a 6x, and then we subtract 1 from the power, so that becomes x squared. Then if we differentiate this piece, drop the 2 down as a multiplier, and this becomes 6y, subtract 1 from there, but then this is a y term, so we're going to attach the dy dx in there, and then on the right-hand side, when we differentiate that constant, we just get 0. Now we want to solve to get dy dx alone, so I'm going to subtract the 6x squared over to the right-hand side. So this is going to say negative 6y dy dx is equal to negative 6x squared. I'm going to divide the negative 6y over to the right-hand side, and doing a little reducing, we get dy dx is equal to x squared over y. But now we have to do the second derivative. So we're going to do another derivative looking at this x squared over y. And because that's a fraction, we're going to have to use the quotient rule. So the x squared is our u, and the y is our v value. So the quotient rule says keep the v piece the same, so just y, times the derivative of the u piece, so the derivative of x squared is 2x, minus, now we're going to leave the u thing the same, so x squared, and then the derivative of y is just 1, but we also just differentiated a y, so we have to attach the dy dx, and this is all over y squared. Now, to simplify things down, I'm going to work on splitting up my fractions. So this is going to be y times 2x over y squared minus x squared over y squared. And I'm going to separate this dy dx off of here. So times dy dx. I can do some canceling in the front here with this y on top and one of those y's on bottom. So this says 2x over y minus x squared over y squared with our dy dx attached on the end. But now there's one more step that we're going to take, and it's with this dy dx, because earlier we actually figured out what dy dx was in this step right here in red. We figured out that dy dx was x squared over y. So I'm going to take that and plug that in right here for the dy dx. So then this is going to say 2x over y minus x squared over y squared times x squared over y, since that's what dy dx was equal to from earlier. Now if we multiply these pieces together on the back end, this will say 2x over y minus x to the fourth over y cubed. So this is our second derivative of that implicit function. Now because we have some fractions in here, we do have to be a little careful with y on the bottom. We do need to make sure that y is not going to be equal to 0 in order for this to exist. That's going to be it for this video. Thanks for watching.